Hello students, today's agenda is to check homework. We're going to be learning about horizontal stretches and compressions, and you will be able to work on 7.5. Today students will be able to identify the effect of horizontal stretches and compressions. So this is a concept that is similar to the one from before, 7.4, but I want you to know that horizontal means from side to side, okay? Horizontal. Last was vertical stretches and compressions, now it's horizontal stretches and compressions. And so when we're talking about horizontal stretches, if I have like an accordion, look at what happened to the picture. Okay, let's say that this was its regular state, which is not, but let's say that this was the regular stretch. When we stretch it, it's like when we multiply by a whole number. So look at the picture of Washington. It widens, right? It stretches on this direction horizontally. At the same time, if I compress, look how he gets skinnier, right? That's when we multiply by a fraction. And I'm gonna have this in hand when I'm working with you on the graphs, but it's just kind of like to see what really is what is happening. Okay, so whenever you have, just like you saw with the bill, with the $1 bill, when you have a horizontal stretch, it means that if you have a graph that looks, let's see, let's do y equals x squared this time. And this is your regular graph. Okay? If we have y equals 3x squared, but then this is between parentheses. That's the difference between the previous one. The vertical stretch, it was just y equals 3x squared, and each point would go up. But in this case, when we're multiplying by a whole number, what this is doing is making everything, like this point arriving on time 3 times as fast. Okay, so it's not gonna happen in here, but it's gonna happen right here. And so this point is gonna be right here. So it's basically a whole number compresses the image or the graph. Okay, instead of this point happening here, it happens 3 times as fast, and so on. And so my new graph will go something like this. Okay? Again, when we multiply by a whole number, it compresses the image, or in this case, the graph. What if I multiply by a fraction? This is my original. And so y equals, again, only if it's between parentheses, then it's an horizontal stretch. Okay? So instead of being here, this point goes over here, and this point goes over here. It's like I'm stretching it, okay? So a fraction inside of a parenthesis means it's being horizontally stretched. It's a horizontal stretch. Remember that before a fraction meant a vertical compression, okay, instead of stretch. And in here is the opposite. A whole number bigger than 1 is a compression, when as before it was a stretch in vertical. Okay, so let's see. A whole number, when we multiply by a whole number inside of a parenthesis, means it's a horizontal compression. Sorry, yeah, I'm running out of space in here, but you get the idea, okay? So if we have a fraction, then each point stretches horizontal, and therefore my new graph will be here. Okay. If you remember, we learned in Unit 6 a little bit about when we're multiplying by a whole number, it means this happening twice as fast. So that's why you get to that point faster. Instead of at 3, you get to it at 2. The other point, instead of getting to it at maybe, I don't know, 7 or 6, you get to it at 3. Okay, so you're getting to the point three times as faster. Okay, 3 times as fast, sorry. Okay, what if I multiply okay, if I have f of x cubed, this will be my regular graph, my mother graph. But then I will graph f of negative x cubed. Now this time the negative is inside of the parentheses. So my mirror will not be my x. My mirror will be my y, or line of reflection. Okay, the line of reflection is not going to be x but y. Now you will notice that it doesn't matter for cubes, you're going to end up with the same, because before, when there was no parentheses, this would go down here. Now what's going to go down in here is going to be this one, because my mirror is here, so this reflects on this side. But if you notice, it would be the same reflection here. And then this reflects on the left. So whatever is on the right goes to the left, whatever is on the left goes to the right. How or why am I doing with this example? Because if we do f of x squared, that's going to be a parabola. And f of negative x inside of the parentheses square, this means that this side of the graph is going to go over here, okay? Because remember, this is my line of my mirror, my line of reflection. This goes to the left goes to the right. So what happens? Well, again, all you're doing is this, okay? You're just switching left to right and right to left. In here, same thing, but if you have something like, let's see, how can I use my hand? If you have something like this, then all you're doing is swapping it, so now it looks like this, okay? So left to right, right to left, okay? You're just switching them like that, or flipping them. Okay. Maybe I'll give you the definition just so that you have it. If the number is negative inside of the parentheses, that's very important, inside of the parentheses, it flips the graph vertically. It flips the graph vertically. That means about the y-axis. Okay? Let me just put this in here, which is kind of like an example of my bill here. If you multiply inside of a parenthesis, if the number is bigger than 1, the graph compresses horizontal. So whole number, it does this. Okay? Inside of a parenthesis, if the number is a fraction, the graph stretches. Okay, so it would be doing this. And see how the picture widens? Mr. Washington widens. Okay. And I just want you to actually kind of like a recap of last lesson, and this lesson is, if the negative is outside, the line of reflection is my x, so it flips upside down. But if my negative is inside, my line of reflection is not x, but rather y, so it just goes from left to right and from right to left. Okay? So negative outside goes down, flips upside down. Negative inside flips left and right. Okay? And I think that's it for this lesson. You're ready to graph or to work on 7.5.